Telescopes have offered us a peek into the universe. It contributes to a greater understanding, looking above and beyond. With it, celestial objects are put to front, leaving a tremendous impact on humanity. Space has mystified humanity since the dawn of time. We can trace it back as far as 1609, when Galileo Galilei created the famous idea of telescopes. The telescope he first designed was a mere tube with two lenses, a refracting telescope, which used concave and convex lenses. Galileo worked with telescopes until he found a spyglass that can magnify something by 20 times. It was an amazing feat. With it, he saw a ribbon of light, which was the Milky Way. He also pointed out the moons of Jupiter, and discovered that engravings on the moon are actually craters and mountains. From then on, the drive for a clearer look at the heavenly bodies continued. With numerous astronomers and engineers contributing to the field, we arrive now at the present day when several telescopes have changed astronomy for the better. The Hubble Space Telescope, the Corot Telescope, and the Kepler Telescope are some of them.
Here is a brief overview of the three. So first up, the Hubble Space Telescope. The Hubble Space Telescope, a large observatory in orbit, was named in honor of the visionary astronomer Edwin Hubble. Since its launch and operation by the Space Shuttle Discovery in 1990, the Hubble Space Telescope has revolutionized astronomy. Hubble has allowed researchers to study some of the universe's most distant stars and galaxies, as well as our solar system's planets. During its existence, Hubble has recorded over 1.5 million observations. On its discoveries, more than 19,000 peer-reviewed scientific publications have been published, and the observatory has contributed to every contemporary astronomy textbook. It was designed to observe everything: stars, planets, galaxies, you name it. Hubble saw it.
Next on the line is the Corot Telescope. Corot stood for Convection, Rotation, and Planetary Transits. Launched in 2006, the Corot mission transformed astronomy by being the first mission to find rocky planets bigger than Earth around nearby stars. It detected exoplanets through their transits, monitoring the dimming of stars when planets transit in front of them. The Corot Telescope has discovered 34 planets since its launch to its end in 2013. One of them being Corot 7b, an exoplanet 522 light-years away from our home. The Kepler Telescope was meant for something similar to its predecessor. It was meant for our quest to find a habitable planet out there. The Kepler mission's main objective is to scope out habitable planets in our Milky Way by analyzing its structure and diversity of its planetary system. Since its launch in 2009, the telescope has imaged thousands of stars which host exoplanets. The exoplanets, one of which is Kepler 186f, the first rocky planet to be found in the habitable region, which resides in the Kepler 186 system. Even after it ceased functioning in 2018, the Kepler telescope continues to impact the scientific community with its information on planets all around the universe. All of these telescopes have changed astronomy in its own way. We can break down the difference between telescopes by analyzing the mirrors, the instruments, operation period, orbit, and vision. Now let's get to the main question. How do they compare to each other?
The mirrors. All of the large space telescopes are reflecting telescopes, meaning that they use mirrors rather than using lenses like refracting telescopes do. The number of mirrors used may vary, but it usually uses two mirrors, the primary mirror and the secondary mirror. The primary mirror's job is to collect light and bring it to the secondary mirror to be reflected to the eyepiece, where the image is magnified. The Corot telescope's primary mirror was just 30 centimeters in diameter. The larger the primary mirror is, the more light is allowed to enter the camera. The planets discovered by it were less than what the Kepler Space Telescope discovered. Kepler's primary mirror was 1.4 meters in diameter, and it was 86% lightweight. It used ultra-low expansion glass. It was honeycomb-shaped, allowing more light to hit the surface, and this design proved sturdy, but also weight-reducing, perfect for a space telescope. Though the earliest of the bunch, the Hubble Space Telescope has the largest primary mirror. Its primary mirror was 2.4 meters in diameter.
2. The scientific instruments. The instruments used by Hubble are the Wide Field Camera 3. This was Hubble's main camera. This camera allowed Hubble to not only see deeper into space but also provide images in the UV visible NIR spectrum, so Hubble can see both visible light and UV light perfectly. The Advanced Camera for Surveys. This instrument was sensitive and precise, perfect for mapping large areas of the cosmos in great detail. Space Telescope Imaging Spectrograph. This instrument uses spectroscopy to split light to individual wavelengths. With this, we can know the temperature, the chemical properties, and the motion of celestial objects. Fine Guidance Sensor. The Hubble Space Telescope has 3 fine guidance sensors, 2 for aiming the telescope to a certain target and the other one is for astrometry, which is measuring the precise positions and motions of celestial bodies. The Near-Infrared Camera and Multi-Object Spectrometer. NICMOS could observe infrared light. Infrared light can penetrate dust clouds, making NICMOS's ability useful for seeing stars that are obscured by nebulas. The Cosmic Origin Spectrograph. True to its name, COS was meant to study how the universe is formed down to the molecular level and answering questions like how did the elements that are essential to life are formed. Other Hubble instruments like STIS and NICMOS also use spectrography like COS do, but COS is different because it's designed to minimize light bouncing off, making it more efficient.
Since it was meant for something different than the Hubble, the Kepler Space Telescope and the Corot telescope used the transit method to detect exoplanets. Using the transit method, those telescopes detect planets by seeing whether there is a dimming of the star's brightness. If there is, then a planet is transiting in front of the said star. And once detected, the telescope can detect many things just from the dimming. It can detect the size of the planet, the size of the star, the orbital size, and even the temperature of the star. Kepler only used one scientific instrument, which was the Kepler photometer. This photometer continuously monitored the brightness of the stars at a fixed point. The photometer had 42 charge-coupled devices, making it capable of observing over 100,000 stars all at once and measuring brightness accurately. Corot used the following scientific instruments. First, an onboard computer processor, and secondly, a 2-part camera, wherein each part of the camera is meant for different mission objectives. One for exoplanet search, and the other one is for asteroseismology, the study of oscillations in stars.
Number 3. Operation Period. Out of the 3, Hubble is the only one which is still operating to this day. It is an impressive feat since its original life expectancy was only 15 years. It is still working and will continue to remain operational until 2030 or 2040. The base of operation is at NASA's Goddard Space Flight Center. Hubble might still be alive, but the Kepler Space Telescope and the Corot telescope have retired. Launched in 2009, NASA retired the Kepler Space Telescope after 9 years of exoplanet search. Since the location of Kepler is so far away, it's impossible to refuel it. The Corot telescope operated from 2006 to 2013. It was shut down after suffering a computer failure, making it unable to send data back to Earth. Number 4. The orbit. So where are the telescopes? Some space telescopes orbit Earth and some does not. The Hubble Space Telescope and the Corot Space Telescope both orbit the Earth, but the Kepler Space Telescope does not. The Hubble Space Telescope orbits the Earth at low Earth orbit. It is 547 kilometers above the Earth's atmosphere, orbiting at a speed of 17,000 miles per hour. This telescope only takes 95 minutes to fully circle the Earth. The Corot telescope orbits higher than Hubble, 893 kilometers above Earth. This telescope traveled in a circular polar orbit, meaning that it traveled from pole to pole. Unlike Hubble and Corot, Kepler did not orbit the Earth. It orbited the Sun together with the Earth instead in what is called an Earth-trailing orbit. This telescope took 371 days to complete one circuit around the Sun, with an orbit height of 151.58 million kilometers. The advantage of an Earth-trailing orbit is that the telescope won't get covered by the Earth at some point, thus having a clearer view. Kepler also did not need boosting to maintain its altitude.
The vision. The most crucial characteristic of a telescope is certainly how far and wide it can see. the further a telescope can see, the further we go back in time. The more we learn about the origins of the cosmos. The Kepler telescope could detect exoplanets 600 to 3,000 light years away from it. Kepler's field of view covered 115 square degrees, or around 0.25% of the sky. Its field of view was comparable to 2 dips of the Big Dipper. For a space telescope, its field of view is extremely large. The farthest exoplanet found by Kepler is an exoplanet similar to Jupiter called K2-1016 BLG0005LB. It was found by Kepler in 2016. There is no data on how far the Corot telescope could see, but it has a field view of 2.8 times 2.8 degrees. Its optical design is designed to minimize stray light coming from the Earth. The Hubble Space Telescope reaches right through time by seeing up to 15 billion light years away. Hubble's Wide Field Camera 3's field of view is 2.3 times 2.1 minutes of arc. Perhaps one of the most influential images the Hubble telescope caught is the Hubble Deep Field (HDF) image. On it, specks of stars and galaxies strewn over, creating a mystifying portrait of the cosmos. It revealed galaxies that were formed 600 million years after the Big Bang. These telescopes have helped us unveil some of the universe's biggest secrets. With technology rapidly advancing, who knows what we'll discover in the future?